So today we'll be starting with the first session. And in the first session, I'm going to work with a very simple topic, and that's going to be connectivity. So we're going to talk about, we're going to understand the connectivity. We're going to see what we can do and how connectivity impacts performance and what can be done. So in each series, like I said, we'll pick up one topic and we'll focus on that topic, and we'll keep on going until we've covered almost everything. And each of these would be a hands-on session that we'll be working with. So once again, welcome to all of you who've been just joining in, and let's start the session for today. The topic is SQL Server connectivity. I'm going to start by sharing my desktop, and let me pick up a whiteboard there. And what we're going to look at and understand is how does SQL Server communicate and connect, and what can we do in order to basically optimize that connectivity. So we're going to understand the connectivity first, and then we're going to see a small little demo on how we can optimize and make that connectivity better. So that's going to be the topic of what we're going to cover. So you definitely need to be connecting to your server from somewhere. And most of the time that would be from either where your web server is, where your web applications reside. So the connectivity will be from your web server to your database server, or it could be from your report server to your database server. But the connectivity or the connection is being initiated somewhere. So let's call this the client where you're going to initiate the connectivity. Now, this client, in order to communicate with SQL Server, will need to, and most probably you have a query here which you're going to run, maybe you're selecting something or whatever. So there is a query which you're trying to run, and you need to send this to your server, which is basically SQL Server, which is residing either in the same network or not in the same network. And that's more a question of whether you're going to be using a public IP to access it, or a DNS name to access it, or a local IP and a DNS name maybe from your local domain controller. So irrelevant to where you're accessing it from, now you have two different machines. So at least the machines are two different ones, your client and your server. Now, when you initiate this connection, the first thing that this connection or this client needs is a driver to be able to initiate that communication. So your first requirement would be for a driver. And with SQL Server, a lot of people don't focus on this at all, because if you're working with SQL Server, you're on, in recent times, of course, you can have SQL Server on Linux, but otherwise it was always on Windows, and your clients are Windows. So you had this driver by default, and you didn't really bother about it because the driver simply allowed you to connect. But for those of you who worked with other databases, let's say you were using Postgres or any other database, you will know the amount of trouble those drivers give you. You'll have to basically find the right driver, install the right driver, and only then your communication or your connections would succeed. With SQL Server also, there is a driver requirement here. And like all drivers, there are two types of drivers which you have. One is native and one is third party. Now, the difference between native and third party here is actually very simple. If you're talking about native, it's a driver which is provided to you from Microsoft by SQL Server team, and it is built keeping in mind all the features that you have and everything that needs to be supported on SQL Server. So naturally, no questions about it, the best driver to use to communicate with SQL Server would be to use the native driver. And of course, the native driver is based on OLEDB, so it's definitely an OLEDB driver which you're looking at. Now, there are some places where you cannot use the native connectivity because, for example, if you're developing a C program, you will not be able to use the native driver from there. And then you might need to use third-party drivers, which normally will be your third-party ODBC drivers, which you use to connect. Now, there are plenty of vendors who provide you these third-party drivers, and if you're using a third-party driver, it is very important to analyze the features they support and what they don't support, because the third-party drivers do not come with the entire feature set. So there would be some limitations in using these drivers. So preferably always use the native driver where you can, and use clients that support the native driver. Now, what is the job of this driver? Assuming that we are going to talk about using the native driver all the time, let me put a green mark there. That's what we would prefer you to use, assuming that's what you're going to be using all the time. What does he do? This guy would pick up your packet from, it will pick up the query which comes in from your client. The native driver now understands what are these conditions and standards required for you to communicate with the server. In simple, he understands the protocol that is understood by SQL Server. Protocols, like we all know, is a set of rules. So this driver understands those rules. So what will he do? He picks up your query and he packages it into a packet. But this packet follows the protocols required for SQL Server engine to be able to understand and interpret this packet. The protocol used by SQL Server is a private protocol, and the protocol is called TDS, Tabular Data String. So what does the native driver do for you? He picks up your query, he basically puts it into a TDS packet. We call this a TDS packet, which means now it is ready for SQL Server to understand, interpret, and pick up the information out of this packet. For those of you who are trying to basically figure out what is TDS packet, that's only for visualization. At the end of the day, it's an XML file, but the XML file follows all the instructions and standards that are required for SQL Server to be able to interpret what you're asking it to do and what needs to be done. So now this XML file or this TDS packet, you can refer to however you want, is now has another challenge. We now need to move this packet across a network, because now you've got the server and the client on different machines. So to move it across the network, it will now basically need to use a network protocol. Now the network protocols comes with rules of how a packet can be safely transmitted across the network, how it ensures that a handshake happens after the packet is transmitted. So there are a series of protocols that you can actually use here. TCP/IP being the primary protocol used by SQL Server, which is the default which you will be using. Now, and so the protocol is selected, the network protocol is selected, and that protocol is used to transmit this packet across the network to reach the server. So here you basically use the network protocols. This also needs to be configured. And this is where in the demo today we will be showing you about how this could impact your performance and what needs to be done here in order to configure the right network protocol usage when you're using SQL Server and you're communicating from one machine to the other. Where it's client-server communication, you're looking at two different machines involved. Once this packet is basically sent across, now what is the packet size is something which you need to configure. That's most probably something which a lot of SQL Server guys feel is the networking guy's job, but it's good to have knowledge of this and understand this. Depending on the bandwidth that you have, the network packet size would be decided. So in case this packet is too large, it will get split into smaller packets depending on the network packet size set. And these packets will be transmitted in chunks across the network to the server. On the server side, you have something which is called Open Data Services. Which is supposed to receive this packet. Oh, forgive me for that. Let me just wipe that out. Before he reaches Open Data Services, he will need the network component here to receive these packets. So first you will need to have a receiver here who's able to basically pick up these network packets and receive them. So now you will basically have a receiver here who will receive the network packets. Now these network packets are basically assembled. So what happened here, your TDS packet which you sent here got converted into a network packet here, which now is following the network rules. So here you have a network packet, and it is following the rules that need to be followed depending on the protocol that you're using to transfer data across the network. So this network packet now basically is sent to the server, and what it receives here is not a TDS packet. What he receives here is a network packet. Now, this network component is supposed to basically assemble this packet back again, do a handshake with your client, ensure that whatever was sent was received safely. So sometimes you might basically get this checksum error when maybe you lost some packets during transmission. So you'll get an error which normally will basically have something in that error message which will say checksum error, because when these packets were being checked on your server, it couldn't find the same checksum value, which means during transmission something changed or something got lost. Now that's the reliability of these network components. Once these network packet is received here and it's assembled, handshake done, and he's sure that there was no loss during transmission, he will now convert this back into the original packet that was given to him, and that was the TDS packet which we spoke about. So he gives you back a TDS packet. Now this TDS packet is passed on to the first SQL Server component, which is called Open Data Services. And this guy now knows how to interpret and understand the instructions in this packet because it is using the rules and protocols which it was designed to understand, because your native driver has taken care of ensuring that this packet now is designed in a language and a set of rules that are understood by your server. Once the ODS picks this up, the Open Data Service picks up this packet, interprets the instructions. Now, the instructions of what has to be done is basically sent to another guy, which is going to be the primary focus of this training, which is the optimizer. Now, the optimizer's job is to basically understand, it knows the instructions, but it needs to understand which is the best way, fastest way to execute these instructions. So that's what optimization does. We'll be spending a lot of the sessions in these series. We've not really set an end date to this series because we're just going to go on until we've covered everything. So by the time the series is over, you would have understood this particular guy completely, because that's the main component of how your queries are executed, how you can optimize them, how you can performance tune them. So the optimizer's job is to find the best way to execute that query. And once he's found that best way, he will now basically decide to compile that query. And once it is compiled, it will go on for execution. I'm leaving the rest of this communication out. And we'll be spending a lot of time, as I said, on this particular component. The reversal is the same. Once the optimizer compiles the query is executed, the results are sent back to ODS, a TDS packet gets built. So you can see the reverse traffic flowing in a similar fashion until it reaches back your client. Again, a TDS packet is sent. So your native driver again is required in order to interpret the TDS packet, pick up the result set from it, and pass it back to your client. And now your client has the result set and can do whatever it's supposed to do with that. So this is the basic communication architecture, which really works. And in today's session, I wanted to basically cover a small little demo, which will tell you how you can configure and ensure a better performance. Now, one question, of course, which I would love to ask is if I open a SQL Server Management Studio. Now, this is a machine just giving you the environment I'm using for this demo, which has a SQL Server Enterprise Edition, which is already installed. We have the Management Studio here. This is a single machine. So when I open Management Studio on this machine, and I want to connect to the SQL Server, what is the default protocol that he's going to be using? So I'm just waiting for that Management Studio to open up. And who chooses the protocol? Now this is, and we're going to align this with performance. We're going to align this with how this basically makes it faster. And we're going to talk about a couple of configurations that you can change here to make it faster. But looking at it from the angle, the thinking that I would like you to start thinking about while that Management Studio opens right now is who makes the choice of protocol? Is it the server? Is it the client? Who's going to choose which protocol am I going to use? See, TDS is not a choice. You have to use the tabular data stream protocol. That's not the choice. So if you go back to the diagram which we had open on my whiteboard, what I would like to highlight is this is not a choice. This has to be used. TDS has to be used. The choice is only about which network packet you're going to use to transfer this across the network. That's the only choice that needs to be made. Who needs to make this choice? Is it the client or is it the server? Now, to answer that question, the client makes it, and SQL Server Management Studio right now is my client. So when I click on Connect Now, this guy is going to decide which network protocol he's going to use. And how he's going to decide that is because you have something called the SQL Server Configuration Manager, where you actually, I think most of you have used the SQL Server Configuration Manager to start, stop, and pause the SQL Server services. However, I don't know how many of you have actually worked with it in terms of basically understanding the network configuration. You will notice here, there are two other components, which is here apart from the services. You will find there are network configurations here. You have the SQL Server network configuration 32-bit, which you don't have to worry about anymore because we are all on 64-bit, but the component is still there. And you also have the client configuration 32-bit. You also have SQL Server network configuration and the client. Now, this is the difference. Why you have 4 here is one is 32-bit and one is 64-bit. So if you're working with a 32-bit client, you need to configure the 32-bit client configuration. Servers, of course, are not 32-bit anymore, so you'll always be using 64-bit. So this is the 64-bit server configuration. And this is the client configuration. Now, by default, the choice of protocol, network protocol, is made by the client. And how he makes that is, so if I go to the client, right now, this machine for us could be a little confusing, so don't get confused. We have the server and the client on the same machine. So we don't have two separate machines here. It's the same, at least in this demo environment. But even if it was separate, the concept remains the same. So the client now, Management Studio in my case, which I've got open and ready to say connect, this guy will choose which protocol to use. And why will he make that choice and how will he choose that is based on what you see in this configurations right here. So you will see here the client configuration. And if I click on client protocols, you will see here the first choice the client has is shared memory. You see three protocols have been enabled here. You can enable more protocols as long as you install the necessary softwares and drivers to be able to support that protocol. You can use name pipes, Banyan vines if you're working from Mac. So you can decide which protocol you want to use. Now the client here, by default, you notice is configured to first try shared memory. Now, shared memory is a protocol which can only be used. I repeat, it can only be used when the client and the server are both on the same machine, which is true in our case, right? But most of your production environments that you're working with, this is not true. Your IES machine is a separate machine where your web servers are, your connection is being initiated from there, and your server, your SQL server is another machine, separate machine. So shared memory will never get used. However, the default configuration, if you've not changed this, is telling the client, anyone who's trying to initiate a connection here will say, first try shared memory. And now when he tries shared memory, because you've said that this is not the problem with the client, you've configured it to say, first try shared memory, because that's the default configuration. So he will try shared memory. And if shared memory fails, now shared memory will fail if the server is not on the same machine as the client. If it fails, it will then go to the second one, which is TCP/IP. Now, this is the performance focus here. So what I would say is, please install SQL Server Configuration Manager on your IES machine because it would not be there by default. Please check the configuration of the client and ensure you disable shared memory like you're seeing me do right now. Simply say no and say, okay. Now, when you do this, TCP/IP becomes the primary protocol. This will ensure your client is not going to try shared memory first, because he should not, because he cannot use shared memory, because your machines, in the current scenario, it is good that he uses shared memory. I don't want him to use TCP/IP because my client and server is on the same machine. But I think in reality, that's going to be a far lesser scenario than the demo which I'm doing right now. So please install the configuration manager. If you go to SQL Server installation, you will find connectivity components. You will find the configuration manager client there. Please install this on your IIS machine and disable shared memory, ensuring that the first attempt is TCP/IP. And you may not notice a huge noticeable performance difference, but guys, there is going to be a difference here, because every time you initiate a connection now, you are going to straight away use the correct protocol, that is TCP/IP, and not shared memory. You aren't going to make an attempt on shared memory and then basically retry TCP/IP because shared memory is not working. You've set the right order. So this is one thing which you can actually do straight away on your client machines. Apart from that, if you look at it, see, one thing is to choose which protocol to use on your client. On your server, now this one will be on your SQL Server machine. This will not be on your machine which has the client. This will be on the machine which has SQL Server installed. You can go and check whether those protocols are enabled. Because while the client chooses the protocol for communication, the protocol needs to be enabled on the server for it to be able to receive that request and respond back. For example, in my client protocols here, you can see I've got TCP/IP as first choice and name pipes as second choice. And hopefully TCP/IP will always succeed because that's the default protocol, should work on Windows to Windows. But here you notice I've got shared memory enabled, I've got TCP/IP enabled, but I've got named pipes disabled. So this means if by any chance my client fails TCP/IP and tries name pipes, I mean, would you really want it? Because if you don't want name pipes here, you can disable it. But based on what you see right now is, if he fails TCP/IP and he goes to attempt name pipes, it will still fail because on my server, I've got name pipes disabled. So you need to have the choice is always made by the client of the network protocol, not by the server. But the server needs to have that protocol enabled to be able to receive and respond to those requests. So that's one thing which you can do. Second thing is, this is not about optimization, but since I'm on the screen, it's very tempting to basically tell you about it. If I double click this TCP IP and I go to IP addresses here, you will basically see the port, the TCP port, which is being used in order to connect to this machine. It is always good to change the SQL Server port so that you're not using the default port 1433, because using the default port would basically ensure everybody would be able to, especially if you got a public endpoint, it means anyone could connect. By changing that port number, you make it a little more complicated for people who are trying to do brute force attacks on your SQL Server, because they won't know the port number and you're not using the default 1433. Okay, so you can change that port number here. But if you change that port number when you're connecting, you'll need to give the port number also to SQL Server. And now when I click on connect, you will notice my system is going to take a little longer to connect now because you could have connected faster if you use shared memory. But unfortunately, I've disabled shared memory. So right now, SQL Server will basically use TCP IP to communicate with the backend server and be able to basically connect to it successfully. In this case, it's a wrong practice to have disabled shared memory because my client and server were on the same machine. But if they were on different machines, then it's a good practice to do that. So in today's lesson, we've understood communication. We've seen how we can basically interact with SQL Server, and we've given you a small little tip of going to your configuration manager, installing configuration manager on the machine, which is initiating the connection to SQL Server, and going to the client protocols there and ensuring shared memory is disabled. If your client is a 32-bit machine, then please go to the client protocols. By the way, Management Studio is 32-bit, it's not 64-bit. Okay, and we will disable shared memory here too. Okay, so any client communication now will start with the TCP IP as the first attempt and not shared memory. Okay, for this, all you have to do, simple step, no impact. There's going to be no negative impact. There's going to be no downtime. There's no restart required of your machine. All you need to do is install the SQL Server connectivity components in the configuration manager tool, go to the configuration manager and disable the 32-bit shared memory and the 64-bit shared memory to ensure you've saved a couple of microseconds, very tiny microseconds in attempting a connection that anyway would not work, the shared memory, and going straight to attempt the TCP IP as the first attempt of making a connection. With that, I will end today's session, but if there's any questions that you guys have on anything that was said today, please let me know. We will continue to keep these sessions short and simple, with one component being covered every day. So that's the component for today. Any questions, I would be happy to take. I guess there's no questions. So cool, guys. Cheers. Have a good. Oh, there is one. Please go ahead.
Yeah. Okay. So this is Gaurav. I had one question.
Yeah.
So if you had a shared memory disabled in your client server and TCP1 is enabled, okay, and in your server, web server, you have your shared memory and TCP both are enabled. That shared memory is at first priority, okay.
Right.
So will handshake happen in the first try because the client server is going with TCP and web server is going with shared memory as first priority? Will the handshake happen?
It will happen because just a very good question, by the way, Gaurav. So thank you for that. Okay. If you look at the server protocols, okay, you can see here, I've just clicked on the server. Oh, sorry, I stopped sharing my screen. 1 second. Let me share that back. Sorry. Okay. So I'm just going back to answer that question with showing you the options. So if you notice, when I go to the client configuration, I have order 1 and 2. But when I go to the server configuration, I don't have an order. I only can enable and disable. Because like I said, the client makes the choice. If the client chooses TCP IP and he tries to make the communication, all you need to ensure that this is enabled. The order does not matter. Okay.
Yeah, okay.
As long as it's enabled, no problem. So yes, the handshake will happen, your communication will happen because there is no concept of order at all in terms of the server network protocols. It is only about enabling them and disabling them. But since the client has to make a choice, there is an order for him as to, there are multiple protocols here. Which one do I choose? So you need an order here, but you don't need an order on the server because this guy's job is just to basically ensure he honors the request of every client. So if I initiate the conversation in English, the server needs to respond in English. Okay. If I initiate the conversation in Chinese, the server needs to respond in Chinese. But the server does not make a choice. He has no priority. He just needs to be enabled or disabled. Hope that answers the question, Gaurav.
Yeah.